Okay, welcome back to our trigonometry series. This going further with Darlington and still the teacher, Darlington arranged the Okay, we'll still be solving some WAEC questions. Today we're going to solve a question on angle of elevation and depression. It's also a very typical WAEC question. Okay, so if you look at this question, let's read it together. We have from an aeroplane in air at a horizontal distance of 1,050 meters, the angle of depression of the top and base of the control tower at an instance are 36 degrees and 41 degrees respectively. Calculate correct to the nearest meter the height of the control tower and the shortest distance between the aeroplane and the base of the control tower. So the first thing to do is to draw it. You have to interpret it in a diagram and clearly, neatly interpret the question. That is actually the main mark. If you don't draw it properly, it's assumed that you cannot get the work. You cannot get the answer if you don't draw it properly. Therefore, so let's draw the question. Let's interpret this question in a diagram. So the first thing here is we have an aeroplane. So let me call this point A, the aeroplane. And then we have a control tower. The aeroplane is not directly on top of the control tower because it was given that it is at a horizontal distance of 1,050. So horizontal distance, this is the vertical distance between the aeroplane and the base of the control tower, and this is the horizontal distance between the aeroplane and the base of the control tower, which will also be the horizontal distance between the aeroplane and the top of the control tower. Okay, let me assume that T, this point is the top of the control tower, and here is the base of the control tower. Now, the angle of depression is actually the angle between the horizontal and your eyesight when you are looking at an object below you. So, this is the horizontal, okay, and your eyesight. So, the angle between the horizontal and your eyesight when you are looking at an object below you. So the angle of elevation of the top of the control tower is what I've just drawn, and the angle of depression, of the top and of the top from the aeroplane is what I've drawn. And so from the aeroplane, the angle of depression is given to be 36 degrees, and the angle of elevation of the bottom of the control tower from the aeroplane is given as 41 degrees. So this is it. So you have 41 degrees. So this is the angle of depression. 41 degrees. Okay. The angle, there's a theorem here that says that the angle of elevation and depression between 2 points, between any two given points are the same. So the angle of depression from the aeroplane is the same as the angle of elevation from the top. So the angle of depression from the aeroplane to the top of the control tower from the aeroplane is the same as the angle of elevation from the top of the aeroplane from the top of the control tower. So this 36 degrees is the same as this. So if you draw the horizontal at the top, the angle of elevation is this. So this angle here is also 36 degrees. And similarly here is also 41 degrees. Okay, you could see that is it's gotten from alternate angles. So this, you can see this. So this angle here and this angle here are alternate to each other. Alternate angles form Z. So you have Z. So that's that. Then this is Z, alternate angle. So you have that. So the angle here is 41. Also here it is 41. Okay, so we've interpreted it in a diagram. So the next thing we have to do is to solve this. Now, in angle of elevation and depression, you will observe that the triangles formed are right angle triangles, because if you observe, the horizontal distance here is 1,050. So you could see the vertical and the horizontal, the angle formed is 90 degrees. So whenever you have any vertical point at the horizontal, the angle formed is 90 degrees. So you can see right angle triangles. You can see, let me assume here is say point X. So this distance, this triangle AXB is a right angle triangle, and then let me assume here is point say Y. This triangle AYT is also a right angle triangle, and then you know you observe that this horizontal distance between the airplane and the base of the control tower will be the same as the horizontal distance between the airplane and the top of the tower, because of opposite sides of a rectangle are equal. Therefore, here is 1050, here is also 1050. So, okay, so if we observe from triangle AYT, okay, from triangle AYT, which is a right angle triangle, the side AY, okay, so AY, the side AY, all over 1050 is equal to the ratio tan 36 degrees. So if you observe that, you can see from this right angle triangle, this is the opposite, and tan is opposite all over the adjacent. So opposite all over the adjacent is the same as tan 36. Okay, now with that, if you make AY the subject of formula, AY will be equal to 1050 times tan 36 degrees. Actually, getting this is not what I'm looking for. I'm looking for the height of the control tower, which is the first question. The height of the control tower is the distance between y to x, which is just from t to b. Y to x and t to b are the same because opposite sides of a rectangle are equal. So if I get y to x, I've already gotten the same. I've gotten the distance, the height of the control tower. So how do I get y to x? I need to get the distance from a to y and get the distance from a to x, because in a to y is a side of a right angle triangle, and a to x is also a side of a right angle triangle, the bigger right angle triangle. You can see the bigger right angle triangle ABX. So if I get the distance between a to x and I get the distance between a to y, then for me to get y to x is just I have to subtract the two distances I've gotten. So the first thing I did now is to get the distance from a to y. Then similarly, I can get the distance from a to x using the big right angle triangle ABX. So from triangle ABX, if we do the same thing similarly, if you look at triangle ABX, this is 41 degrees. Okay, you understand how I got that 41 degrees again? Remember, alternate angles. Okay, the angle of depression of the base from the aeroplane is the same as the angle of elevation of the aeroplane from the base, so that they are the same. Okay, so let's continue. So similarly, AX, that is opposite to 41, with respect to 41, opposite over the adjacent is the same as tan 41. So AX all over 1050 is the same as tan 41. So if you make AX a subject, so the distance from A to X will be 1050 tan 41. Now, therefore, the height of the control tower, will be gotten by doing the distance from A to X minus the distance from A to Y. Okay, so it will be gotten by doing A to X minus A to Y, and A to X is 1050 tan 41. I didn't just want to get the value, minus 1050 tan 36. If you observe, 1050 is in both terms of this expression, so you can just factor out 1050 and then you have tan 41 minus tan 36. Okay, so we just have our calculator, get our calculator and do 1041. Okay, let me get my calculator, please. Okay, so you just have because these are not special angles, so I can't memorize the tan. So you just have 1050 times tan 41 minus tan 36. Okay, so we have that, we press equal to. So So that will give us 149.88. So that's 2 decimal places. Your boy is about 149.88142203. But the question says we should approximate correct to the nearest meter. So we should correct our values to the nearest meter. Therefore, to the nearest meter, it will be 1050. Because when you add 1 to this, it becomes this will be 10, and you add 1 to you write 0 and carry 1 to this place, so it's 1000. It will be 150 meters. Therefore, the height of the control tower is 150 meters. Okay. Similarly, let's solve the next part of the question. Okay, we'll draw this diagram so I can clean this question. Draw the diagram for the question so I can clean it. So the next part of the question says the shortest distance between the aeroplane and the base of the control tower. So the shortest distance is going to be a straight line, definitely. So the distance between the aeroplane and the base of the control tower. So we are looking for the hypotenuse of the right angle triangle AXB, okay, or ABX. Okay, so from triangle ABS, so to answer the second question, from triangle ABX, so from triangle ABX, to get AB is the hypotenuse. We already have the adjacent to 41 degrees, so we work with cos adjacent over hypotenuse. So cos 41 is the same as adjacent 1050 all over AB, which is the shortest distance between the aeroplane and the base of the control tower. So we cross multiply. Okay, so we have AB cos 41 is equal to 1050. You divide both sides by cos 41. So you have AB. Since we have a calculator, we can quickly do that. It's 1050 over cos 41. So we just have 1050 divided by cos 41. Okay, press equal to. It gives us 1391.2636, so on. Okay, but we want to approximate it to the nearest meter. So this is the nearest meter. These are fractions of meters, like decimals of meter. The next is not up to 5, so we round up straight away. So we have 1391 meters. So this is the shortest distance between the aeroplane and the base of the control tower. Okay, highlights, these things to take home. Remember to draw the diagram. It's very important. Draw the diagram. Interpret the question clearly in the diagram. That is what WAEC requires of you. If you don't draw the diagram and you begin to answer a very wonderful question, you might have a teacher that will be lenient and mark it. If the supervisor sees it, he will mark you wrong. But actually what you are required to do, because you need the diagram to answer the question, so you should draw clearly the diagram inside your answer booklet. So the diagram, remember, angle of depression is the angle between the horizontal and the point below you. So if you are looking at an object below you, the angle between the horizontal and if you are looking at your eyesight when you are looking at an object below you is the angle of depression. And just remember, the angle of depression is the same as the angle of elevation. So between 2 points that are not on the same horizontal level, the angle of depression is the same as the angle of elevation. So the angle of depression of the base of the tower, which is 41, is the same as the angle of elevation of the aeroplane from the base of the tower. And the same, the angle of depression of the top of the tower from the aeroplane is the same as the angle of elevation of the top of the aeroplane from the top of the tower. So remember this diagram. So with this, you have 2 right angle triangles, which is AYT and AXB. So once you identify the 2 right angle triangles, you can actually solve the sides that you need. Solve for the sides that you need, and with that you can get the height of the control tower, which is the first question, and the second question is the shortest distance between the aeroplane and the base of the control tower, which we got as 1391. So with this, we come to the end of this particular problem. we will solve more and more questions in trigonometry in our next class. So we'll continue with this trigonometric series, and then you can see some one algebra in our video series. I'll drop some quick algebraic simplifications that I would like you to get to know. There may not be, some of them you may find them interesting. So please subscribe if you've not subscribed to the channel, like, and then put your questions. I'll go through them. I need your questions actually, because your questions will help me with the next video I'll be doing. Thank you, and remain blessed.